OCI, Orange County Inspections, is glad to present the Quality Control and Quality Assurance Professional Seminar. Segment number 8. The topic to be covered with this segment is the PQR. The first item we will discuss is what actually the PQR is. If you have been in the welding industry for any period of time, you have heard this term and also the term WPS, which we will cover in the next segment. And if you are new, these two segments will save you many hours of frustration and confusion by showing what the PQR and WPS are and how they work. Next, we will review some excellent PQR examples provided by the American Welding Society. Here we will cover each important line item, so when you find yourself covering the qualification process, you will feel confident. Beautiful. Next, we will review some excellent PQR examples provided by the American Welding Society. Here we will cover each important line item, so when you find yourself covering the qualification process, you will feel confident with the basic knowledge of how the PQR works and how it should be filled out. And lastly, we cover the troubleshooting of the PQR. With the new code changes as of 2010, there are PQR essential variable tables that must be consulted to ensure compliance. First, let's start with the basics of the PQR, and that is to answer the question of, what is a PQR? Okay, the letters PQR stand for Procedure Qualification Record, and this is a living document of the actual welding variables and test results that were used to produce an acceptable test joint. Next, this living document qualifies the WPS. And once again, we will cover the WPS in detail with the next segment. And lastly, as of 2010, the D1.1 has provided a new table that covers the essential variables that must be complied with, or the requalification of the WPS is required immediately. Next question is, why do we need a PQR? Section 4.7 of the D11 states the WPS shall be obtained from the PQR, and the PQR shall serve as the written proof of a successful WPS qualification. So, the development of the welding procedure is the first step, and this will precede both the welder qualification and production welding. A quick note. The general intent with the PQR is to not specifically judge the welder's ability, but is performed to show the compatibility of. A quick note. The general intent with the PQR is to not specifically judge the welder's ability, but is performed to show the compatibility of the base metal, and you must ask, is it an approved material within the code? Or is there a need to establish matching of non-approved materials? Next is the process. There are pre-approved welding processes in the D11, but could there be a reason for trying to recognize a unique process? Another item are the filler metals. Again, there are pre-approved filler metals for a certain material within the code. Or is there a special condition for matching different filler metal strengths in question? And lastly are the techniques. Whether it's the position of the electrode, or maybe it's a certain way of removing the backup bar. Next question is, how does a PQR work? The purpose of the PQR is to demonstrate that the four items just covered will produce a weld joint that meets the applicable code and specification requirements. There are four steps that must be followed to qualify a PQR. First step is the preparation and welding of the weld joint. This joint will represent the size, type, and thickness of material and technique to be welded in production. Second step is the testing of the weld joint. The type and number of specified tests and examples will be made Second step is the testing of the weld joint. The type and number of specified tests and examinations will be made on the weld joint. The destructive tests could include tensile, bend, Sharpie V, etc., and often non-destructive examinations such as ultrasonic or mag particle, etc., could apply. But the PQR will state what and how these tests will be conducted. The third step is the evaluation of weld joint test results. A review of the joint preparation, welding, and testing results will take place by the design professional team, which will then analyze The third step is the evaluation of the weld joint test results. A review of the joint preparation, welding, and test results will take place by the design professional team, which will then analyze and determine that it complies with the applicable codes and specification. And lastly, the fourth step is the approval of the PQR. This step will be performed by the authority having jurisdiction. They will review the evidence that shows the weld joint technique and testing. We have come to the second item of this segment, which is review of a PQR sample form. And here we see the first page of a PQR package, which is the recipe of the how-to weld a joint assembly. And the second page here is the test results form. Now let's go through the important line items of these forms for a better understanding. We start with the first page of a PQR package, and like mentioned before, think of this as the recipe of how to weld a joint assembly. So the first item to check for is the actual title of the form, which should be like this: Procedure Qualification Records, PQR. The next item is seeing if this box is checked, because if not, this could actually be a WPS, or this could be the start of having a non-complying PQR, which means the information does not match how the weld joint was produced and tested, or worse yet, the individual filling out the form does not know what they are doing and are just filling in the blanks and hoping that no one will catch on. Okay, let's start with the number 1 star, which covers the line items of the contractor or subcontractor's name for which this PQR is for. Below that we see the type of process being used, and here we see the flux core arc welding process is being used. And lastly is the line item of any supporting PQR number. Star number 2 will cover the line items for the joint design used. First we see the type of joint being used, which is a butt joint. Then, is it a single or double weld? Is there backing being required? Plus, what is the backing material being used? Now, we see the dimension callouts for the root opening, root face dimensions, groove angle, radius, if the J or U preparation is being used. Lastly, is back gouging required? And what method will be used if so? We move down to star number 3, which covers the base material line items. Here the material specification, then the material grade is needed, and notice how you need to circle either the grade or type of material when filled out. Then the material thickness is asked for, and notice the different choices whether it's for a groove or fillet weld. And then the next line item is for the pipe material diameter. Now is a filler metal for star number 4, and this should make sense now, the difference between the specification and classification line items. Star number 5 covers the line items of shielding for the filler metal. If using submerged arc welding, you would place the type of flux being used to cover the arc. Then we see the gas, composition, electro flux class, flow rate, and gas cup size line items if you're using the flux core or gas metal arc welding processes. We move to star number 6, which covers preheat of the weld joint, and there is the line item for minimum temperature of the base metal at the starting of the welding, and the next line item covers the minimum and maximum weld bead temperatures during welding. Star number 7, located on the right side of the form, deals with the PQR identification number, any revision number to this PQR, the date, by whom this form was filled out, whom authorized this PQR to be produced, and what type of welder or machine operation is being used during the welding, whether that's manual, semi-automatic, etc. I don't like that. Star number 7, located on the right side of the form, deals with the PQR identification number, any revision number to this PQR, the date, by whom this form was filled out, whom authorized this PQR to be produced and when, then what type of operator or machine operation is used during the welding, whether that's manual, semi-automatic, etc. Star number 8 covers the welding position and progression of the welded joint. Positions are either flat, horizontal, vertical, or overhead, with a G standing for groove weld and an F representing the fillet weld, where the progression of the electrode is either uphill or downhill only if vertical position is used. Electrical characteristics is covered by star number 9, and here the gas metal arc welding transfer mode is called out. Then the filler metal current is needed, where we see the power source is asked for. CC means constant current, and CV means constant voltage. And lastly, the dimension of the tip used for gas tungsten arc welding are required. Moving to star number 10, and the technique information is placed here, with items such as the weld bead placement type. Is it a stringer bead or weaver bead? Is it a stringer bead or a weave bead? Then are the multi-passes being required, or is a single pass going to be sufficient? Next are multiple electro heads being used, and if so, what are the spacing for those heads? If flux core or gas metal arc welding processes are used, what is the contact tube distance from the weld joint? Is there any manual tooling to the individual weld bead, called peening, being used? And closing with the means of cleaning the individual passes. And the last line item on this form is star number 11, which covers the post-heat treatment. And the last line item on this side of the form is star number 11, which covers the post-weld heat treatment, and if required, what is the temperature to be held at and for how long. Here usually there will be a schedule of times and temperatures to be followed until the minimum is reached, but still that would need to be attached and followed with this PQR. Now let's take a look at a chart that will spell out how each individual pass for the weld joint. Now let's take a look at a chart that will spell out each individual pass for the weld joint, and this chart is called the welding procedure. To start, here is what the weld joint in this PQR will actually look like, and we have a groove weld. Does it match the line items for positions above? Remember, the G stands for groove welds, but you will be surprised how often this simple step is incorrect, which makes this form not in compliance for proceeding with any production welding. Next, notice the groove angle, backing, and root opening. Again, does it match the line items found in joint designs used above? And lastly, we see the individual weld bead passes. We count 7 here in the diagram, but here in this column it has a call out for 16 passes. So what you should see in the diagram is not only how many passes it took to complete the weld joint, 16, but more importantly how the sequence of placing them were done. Next column will state the weld process that should match the line item under the company's name above. Third column from the left covers filler metal, where the class should match the line item for filler metal above, plus it gives the electrode diameter. Here we see the current parameters and again DC positive should match the line item in electrical characteristics, which has DCEP called out, or direct current electropositive. Plus we see the amps being established. Notice how they circle the amps. Now with this PQR using flux core arc welding, they could have circled the wire feed speed, which is the same as amps. We move over to the column that covers volts. If you notice on the line item covering power source above, the question would have to be asked about the CV box not being checked with the use of flux core arc welding. And lastly, we see the travel speed column, which is how fast the welder will move the welding nozzle down the weld joint length. And these numbers represent the inches per minute it will take the welder to complete this pass. We move to the second page of the PQR package, and this is the sheet that actually makes the PQR, which are the testing results. You should see the title call out of Test Results, and the PQR number should match the first sheet within the package. Here we see the tensile test results, which is a destructive test made from the weld joint itself. And this chart shows and establishes the ultimate load, stress, and character of the weld joint. We see there are 2 specimens noted and the actual weld dimensions. Next is another destructive test chart called the guide bend test, where the specimens are once again the actual weld joint and are placed in a hydraulic bending machine, which will reveal any failures within the weld zone, and once again there were 4 specimens. With star number 1, we see the visual inspection line items of appearance, undercut, piping porosity, convexity, the actual visual test date, which could be different from the destructive tensile and bend tests, and lastly, who actually performed the visual inspection. Star number 2 is where any other test not covered by these 2 forms will be placed, such as dye penetrant or mag particle testing. Star number 3 shows where the information of whom and how the tracking of the welder was done, and also the company and for what PQR number and by whom conducted the testing for these specimens. Where with star number 4 is the information for any non-destructive testing such as radiographic or ultrasonic testing. Star number 5 covers the testing results of the fillet welds. Were there any multiple passes used? And the results of the macro etch test, which is a destructive testing using a form of acid to expose the fibers within the weld joint. And the last star is number 6, which reveals another destructive test result called the all-weld metal tension. Here we see the maximum load result the weld joint can handle before snapping in two. Then the point where the metal starts to bottleneck down, which is called a yield point. And then the next item is when the two broken pieces are placed back together, there is an elongation that has taken place. And this is how much is stretched during the testing. And finally, the testing number for this PQR is established by the testing laboratory. To finish, the last item on this form is the statement of certification, which is dated and signed, showing that the proper preparation, welding, and testing were performed for compliance of the applicable code and specifications. The last item to be covered in this segment is the troubleshooting of the PQR. The first issue is the placing of incorrect information on the form that does not match what is being tested. All line items must match what has been assembled, welded, and tested for compliance. If any information is incorrect, it could cause a problem when the production welding begins due to the fact that the parameters will not be matched. The second issue is an incomplete form. Here the form is missing information that describes the how to prepare, weld, and test the weld assembly. As you become more exposed to the PQR, you will see many trying to use a previous PQR, and at times will have you scratching your head on how someone could possibly think they could get it by the authority having jurisdiction. But funnier things have happened in the past. And here is a very important table that is new to the 2010 D11 code, which sets the limitations for a PQR that may require the WPS to be requalified. Here we see the new table for the 2010 D11, and there are 3 pages that cover the items dealing with the PQR. As you look at this table, and if you have any time in the industry, you will notice this looks a lot like the essential variable table for the WPS. So take a moment and make sure you're using the correct table. Second thing is to see how the table is set up before jumping in and trying to use it. So the table has 2 parts, and this is the category column that this table covers. Within this category column is filler metals, then the welding process parameters, next we see the other part of this table, which reveals the welding processes and the actual limitations that will be monitored for compliance. As mentioned earlier, here are the welding processes covered for this table. Next, we have seen this X marking previous in the seminar, and it stands for this being used for the line item and process. Here we see an information call out for this specific line item. And lastly is this empty box, and with the actual code page you will see a gray tint to the box, which means it will not be used. This is the second page of the table, and we see the 2 parts of the table again, and the topics continue from page 1 as with the process parameters. Then the shielding gas, submerged arc welding parameters, and lastly for this page, the general topics. As we move to the last page of the table, we see the 2 parts again, and the continuation of the general topics, which leads us to the footnotes being found here at the bottom of the page. So, how do you use this table, you may be asking? Let's walk through a few scenarios and find out how. We will focus on this topic, the filler metals. And with the filler metals, let's take a closer look at number 3, which covers the changing from electrical classification to another electrical classification, which means if the electrode strength was needed to be increased for some reason, you would need the WPS to be requalified. Now, be careful and slow down and look for these small little letters. These are your footnote callouts, which will give you special information, and in this case, the footnote states the filler metal strength may be reduced without requalification of the WPS. And this is a great example of where you, the QC or QA professional, could cost your company a lot of money in wasted time or in a heavy back charge if this footnote was missed. Next is the X marking found here in the submerged arc welding column, which means this line item will be applicable with this process. And we follow the line across the table, we see another X under the flux core arc welding column. Then again under the gas tungsten arc welding column. And in columns like the shielded metal arc welding or gas metal arc do not have an X, it's not applicable for this line item. Now let's take a look at number 10, which covers the changing of filler metal diameter size, and once again ask yourself, do you see any footnote callouts? If not, keep moving across the table to reveal which welding process is applicable and what is the limitation for that item. And under the shielded metal arc welding column, we see if there is an increase in the filler metal diameter of 1/32 of an inch, it will require the WPS to be requalified. Next column is the submerged arc welding process, and here any increase in size will need a requalification. But do you notice a footnote call out? Again, we move to the gas metal arc welding process, which states the same about any increase but also any decrease. In the flux core arc welding column is an increase. And lastly, with gas tungsten arc welding, a increase or decrease of 1/16 of an inch will require the requalification. We have come to the end of segment number 8, and let's review the items we have discussed covering the PQR. First, we answered the often asked and very confusing questions of what is a PQR, why do we need the PQR, and how does the PQR work? Second, we took an in-depth look at each line item on the example of the PQR form that the American Welding Society has provided for our learning growth. And lastly, we alerted you to the QC and QA professionals, to the new essential variable table for the PQR and how it is structured and performs. The study material for this segment will cover the following. We have provided a scenario plus form so you can create your own PQR. Now do the best you can, and at first we have provided a scenario plus form so you can create your own PQR. Now do the best you can at first, and remember, practice makes perfect. Then we have provided you with a sample PQR for your review and see if the line items are correct. And if any questions arise, just email us at orangecountyinspections@yahoo.com. When completed, move to segment number 9.